Good morning, students. So, as you know, in physics syllabus, we have completed the current electricity chapter and also alternating current, which was the 7th chapter. Okay. So, now I'm just switching on to the next chapter, 8th chapter, that is electromagnetic waves. The 8th chapter in our syllabus is electromagnetic waves. Okay. So in this chapter, we are going to study what are the electromagnetic waves, means the nature of electromagnetic waves and the source of electromagnetic waves, means how the electromagnetic waves have been produced, and then we are studying some characteristics of electromagnetic waves. Okay, means what are the properties electromagnetic waves do possess. Okay, and then we are going to study electromagnetic spectrum. Electromagnetic spectrum. Okay, so this is a small chapter. Okay, in this we are studying the nature of the electromagnetic waves, the source of the electromagnetic waves, characteristics, and electromagnetic spectrum. Okay, these many times I am saying electromagnetic waves. So you may be getting a question, what exactly these electromagnetic waves are? What are those? We have heard sound waves, means whenever we are doing the sound waves are propagating in the air, they are sound waves. We are getting the light waves. Water waves, ripples in the water. Okay, all these things you may studied in your PUC first year. Okay, so what are these electromagnetic waves then? Initially, what is a wave? What is a wave? Okay, let me take a simple example of sound wave. Okay, now a person is standing near to me and I am standing here, and whatever I talk is heard by him. Okay, how this phenomena happens? This is because of the sound waves. So how sound waves will travel? Okay, see here. Here that person is there, his ears are there, and I am talking my mouth. Okay, so in between, what is there? In between his ear and my mouth, there is a air medium, isn't it? There is a air is there, means in the air we are having different layers. Okay, so whenever I talk, the air near to my mouth get disturbed. Understood? Air is a medium between that listener and me. Air is a medium. So whenever I talk, the sound waves are generated and they are hitting the layer of the air near to my mouth. Okay, from one layer to another layer. That disturbance is moving from again one layer to another layer. Means throughout the layers of the air, that disturbance, which we call it as a sound wave, that is moving, and at the final stage it is hitting on the ears of the listener. Understood? This is the propagation of sound waves. Similarly, light waves are also there. From a source of light, we are getting the light in the forms of light waves. Still so many types of waves are there. Okay, ripples waves are there, and so many types of waves are there. Okay, so electromagnetic waves is also one of the type of the wave. So waves is basically what it means. Wave is nothing but it is a sort of disturbance. It is a type of disturbance which is propagating in the medium. Some waves are also there which do not require any medium. Mechanical wave, non-mechanical wave, transverse wave, longitudinal wave, 1D waves, 2D waves, 3D waves, all these things you may know them. Okay, so this electromagnetic waves is also one type. It is a bit different from all those waves. Initially, it is a sort of disturbance only, because waves means a sort of disturbance. So electromagnetic waves are also some type of disturbances. Then which kind of disturbances are these? The name itself indicates electromagnetic. Electromagnetic. So can I split the word electric plus magnetic? Electromagnetic. Understood? Electric plus magnetic. Okay, so in this electromagnetic wave, what we have? We have one electric field and another magnetic field. Understood? And these two fields are varying with respect to time. Means the electric field is also time varying and magnetic field is also time varying. Okay. So these time varying electric field and magnetic field are perpendicular to each other. 90-degree perpendicular to each other, and combinedly they are perpendicular to the direction of propagation. What I am saying, this electric field and magnetic field are time varying. So in electromagnetic wave, what's happening? In electromagnetic wave, these time varying electric field and magnetic field are perpendicular to each other, and they are combinedly perpendicular to the direction of the propagation. Direction of propagation means what? The direction in which they are moving, the direction in which the wave is transmitting. Understood? So how can we define electromagnetic waves? Means, listen carefully. Electromagnetic wave is the one where the time varying electric field and magnetic field are mutually perpendicular to each other, and combinedly they are perpendicular to the direction of propagation. Understood? The definition has two parts. In first part, what we are having, the time varying electric field and magnetic field are mutually perpendicular to each other, and they are combinedly perpendicular to the direction of the propagation. So electromagnetic waves are the one in which the time varying electric field and magnetic field are mutually perpendicular to each other, and combinedly they are perpendicular to the direction of propagation. In your high school classes, you may see this diagram like this. Like this. Have you seen one diagram? Have you seen like this? This is the presentation of electromagnetic waves. Means, if this straight lines are showing the electric field, these lines, they are actually like this. Like this means electric field is like this and magnetic field is like this. 3D. Okay. So the electric field, time varying electric field and time varying magnetic field are perpendicular to each other, mutually perpendicular to each other, and combinedly they are perpendicular to the direction of propagation. Understood? So these electromagnetic waves can travel through the medium, travel through free space also. They can travel through vacuum also, and also they can travel through the medium. Okay, and these electromagnetic waves are transverse in nature. Transverse waves means what? The wave in which the direction of vibration of the particle is perpendicular to the direction of propagation. See here, in this electromagnetic wave, the direction of propagation is like this, and these electric field and magnetic field are vibrating like this. The particles are vibrating like this. You are having one experiment, sonometer experiment you are having now. Can you remember that? Or otherwise you are doing it in this year, I think. What there will be, one wooden chamber will be there. On that we will be having one stretched string we are having, and we are hitting the tuning fork and keeping it over here, and that string will vibrate like this. Means the waves are traveling like this, but the strings are vibrating like this. String in the sense, the particles are vibrating like this, and the propagation of wave is like this. Here also electric field and magnetic field are vibrating like this, but the direction of propagation is like this. That's why we can say that this electromagnetic waves are transverse in nature. Understood? They are transverse in nature, and they can travel through free space or vacuum. So, two things. And one more thing is, electromagnetic waves can undergo reflection, refraction, interference, diffraction and polarization. Okay, so these three important points we studied about electromagnetic waves. So the definition of electromagnetic waves and its three important natures. We have studied what is electromagnetic wave means. The wave in which electric field and magnetic field are mutually perpendicular to each other and perpendicular to the direction of propagation, and they can travel through free space and vacuum. They are transverse in nature and they will undergo reflection, refraction, interference, diffraction and polarization. Understood? So this is all about nature of electromagnetic waves. Okay, so now how these electromagnetic waves are produced, how we can get electromagnetic waves. Okay, so this is studied by the physicist James Clerk Maxwell. He studied how these electromagnetic waves are produced. James Clerk Maxwell in the year 1865. Okay, and he told that these electromagnetic waves are produced by accelerating charges. They are produced by accelerating or oscillating charges. He studied about electromagnetic waves and he gave a theoretical prediction that the electromagnetic waves are produced by accelerating charges. Theoretically, he told that these electromagnetic waves are produced by accelerated charges. That means what? Whenever a charge is at rest, charge Q is at rest, it will be having the electric field around it, isn't it? And when the charge is moving, it will be having a magnetic field around it. You have studied this in the electromagnetic induction. Understood? Electric field will produce a magnetic field around it. Which law is that? You only think which law is that. Okay. Then hence this charge, when it is at rest, it is having electric field. When it is moving, it is having magnetic field. So he predicted theoretically that the accelerating charges will produce the electromagnetic waves. Understood? So this was the prediction given by James Clerk Maxwell. But in the science, we will approve anything if you have a particular proof. Understood? Yes, Maxwell has told that accelerated charges will produce the electromagnetic waves. But how to believe on that? We should have some experimental proof, right? So that experimental proof is given in 1887 by one more physicist, Heinrich Rudolf Hertz. Heinrich Rudolf Hertz or H.R. Hertz gave experimental proof for the Hertz gave experimental proof for Maxwell's theoretical prediction. Maxwell theoretically predicted that the electromagnetic waves are produced by accelerated charges. So to that fact, the experimental proof is given by Rudolf Hertz, and that experiment which will give us the proof for the basic source of electromagnetic waves, that experiment is called as what? Hertz experiment. That experiment is called as what? Hertz experiment. This experiment will give us the basic source for electromagnetic waves. From where these electromagnetic waves are produced, we can understand that by using Hertz experiment. Okay, so what Hertz experiment consists of? Okay, it consists of two copper or zinc plates. I am doing a construction here. Let's call this plate as P1 and let's call this plate, one more plate, as P2. P1 and P2 are the two copper or zinc plates which are kept parallel to each other and they are separated from each other with the distance 0.6 meter. Understood? These two plates are kept parallel and they are separated by a distance of 0.6 meter. And I'll take it a bit down. So this is one more plate P2 and they are separated by 0.6 meter distance and they are connected to two metallic spheres. These two metal plates are connected to two metallic spheres, well polished metallic spheres A and B. Understood? And between these two metallic spheres A and B, we are connecting a induction. Understood? We are connecting a induction over here. Okay. So, and one more thing, here we are having two more metallic spheres with a coil. This is called C and D. To this we call it as a detector. What we call this as? This is a detector and this is a induction coil. Understood? This is the arrangement of Hertz experiment, the construction of Hertz experiment. What we are having over there? We are having two metallic plates P1 and P2. They may be of copper or zinc, kept parallel to each other, separated by a distance of 0.6 meter, and they are connected to two well polished metallic spheres A and B, and between A and B we are connecting a induction, and this here we are having one detector. Understood? So this is the construction. So now how we can decide that electromagnetic waves are produced by accelerated charges? Okay, now start the working. Okay, so what happens here? See, this induction coil will produce a higher potential difference, a highest potential difference of thousands of volt, and it is passed between A and B. From this induction coil of several turns, we are producing a high potential difference of thousands of volts, and we are supplying it to A and B. Okay, so between so the higher potential difference of several thousands of volts is applied to the metallic spheres A and B. Okay, so in between this A and B, what we are having? We are having air. Nothing is there. So this is a air gap. That is the air gap. So to this air gap, if you apply thousands of volts of the potential difference, the higher potential difference, so what happens here? Here what happens? Here we are getting, here it will produce a path for the discharge, and here we are getting a spark. A spark is produced between this air gap. A spark is produced in the air gap between A and B. Understood? Because of that spark, because of that highest potential difference, and because of that spark, here we are getting the electric field in the vertical direction. And because of that spark, we are getting the magnetic field in the horizontal direction. Understood? So here between this air gap between A and B, because of the spark produced, we are getting electric field in the vertical direction, and horizontal direction we are getting the magnetic field. Understood? So if electric field and magnetic field are there and they are mutually perpendicular to each other, so that is just nothing but electromagnetic waves. So like that, here between A and B, the electromagnetic waves are produced by the Hertz experiment. Understood? So by using this detector, we will detect the nature of that electromagnetic wave, and they will be nearly having the wavelength of 6 meter. The electromagnetic waves produced over here, we are detected by the detector, and they are having the wavelength of 6 meter. Understood? So this is what Hertz experiment done, and it gave the practical proof for the basic source of electromagnetic waves. How electromagnetic waves are produced? They are produced by accelerated charges, or they are produced by oscillating charges. Here the spark is producing because of this highest potential difference is nothing but the charges, the high rate of acceleration of the charges. Understood? Because of that, electromagnetic waves have been produced. Understood? So this is about the Hertz experiment and the basic source of electromagnetic waves. Understood? So till now we have discussed the nature of electromagnetic waves and the basic source of electromagnetic waves. Okay. Now let's discuss some properties of electromagnetic waves. So properties means what? If a newcomer is coming in your class for the PUC second year, if you get a newcomer in your class, first what we will do, how he is, you will see, na? Like he's fat, he is thin, he is tall, he is short, how he is. So how electromagnetic waves are? Electric field and magnetic field are perpendicular to each other, and they are the electromagnetic waves. Then what you will do? You will understand his name. You will understand his name. The name is electric field and magnetic field are perpendicular, hence the name is electromagnetic waves. Then you will go for from where he have come, from where that newcomer is coming. So that you understood that these electromagnetic waves are coming from the accelerated charges. And then you will go for how that person is. Is he friendly? Is he arrogant? Is he angrier? How he is? You will try to know, na, that newcomer's properties. You will try to understand. Similarly, here we have studied the nature of electromagnetic waves. We have given the name electromagnetic waves. We have understood from where that electromagnetic waves are coming. So now let's discuss about properties. What are the properties? What are the peculiar characteristics these electromagnetic waves are having? Okay, there are totally 7 properties are there. Okay, so the first one, you already know this. The electromagnetic waves are produced by accelerated charges. This you have know already. The electromagnetic waves are produced by accelerated charges. Second, okay, when this, I told initially that the electromagnetic waves can travel through free space or vacuum, or they can go through any medium. Okay, so now when the electromagnetic waves are traveling through free space, they will be having a speed c is equal to 1 by square root of mu naught epsilon naught. This will be the speed of electromagnetic waves when they are traveling in the free space. Understood? They will travel with the speed of c in the free space, and c gives rise to 1 by square root of mu naught into epsilon naught. What is this mu naught and epsilon naught then? The mu naught is permeability of free space, and epsilon naught is the permittivity of free space. This is when they are traveling in the free space. If they are traveling in any medium, they will travel with the speed of v is equal to 1 divided by square root of mu epsilon. When they are traveling in any medium, they will travel with the speed of v, and that v is nothing but 1 by square root of mu into epsilon. Mu is nothing but the permeability of the medium, and this epsilon is permittivity of the medium. Understood? This was the second property of the electromagnetic waves. Okay. Third property. The energy of electromagnetic waves is equally shared by electric field and magnetic field. Energy means capacity. The electromagnetic waves are obviously having some amount of energy, and whatever the energy they possess is equally shared by electric field and magnetic field. Understood? So this is the third property. Fourth, the electromagnetic waves will transfer energy and momentum. The electromagnetic waves will transfer energy and momentum throughout their propagation. This was the fourth property. fifth. This electromagnetic waves, as you know, they are having electric field and magnetic field. So the magnitude of electric field E and the magnitude of magnetic field B, their ratio will give us the speed of propagation of electromagnetic waves. What is the fifth property? The magnitude of electric field and magnetic field. The ratio of magnitude of electric field and magnetic field will give us the speed of electromagnetic waves. This is the fifth property. Okay, next, the intensity. Intensity means waves will be obviously having some intensity, and the intensity of electromagnetic waves is given by epsilon naught C and E RMS square. E RMS square, epsilon naught C E RMS square. E RMS is nothing but RMS value of electric field, and that E RMS is equal to epsilon naught into divided by 2. Epsilon naught divided by 2. Means here we are having the E naught. E naught is the maximum energy of the electric field. In the alternating current chapter you have studied na, RMS value, maximum peak value, understood? So this E naught is peak value, means maximum value of the electric field, and RMS value of the electric field, and it is the intensity. Okay, so the last property is in this electromagnetic waves, the electric field and magnetic field are in phase. What is in phase, what is out of phase, we have studied in detail in the chapter alternating current. Yes. So at any instant, at any point, these electromagnetic waves, in the electromagnetic waves, the electric field and magnetic field are in phase. Understood? So these are the 7 properties of electromagnetic waves. Electromagnetic waves are produced by accelerated charges. When they are traveling in the free space, their speed will be, their velocity will be c is equal to 1 by square root of mu naught epsilon naught, and when they are traveling in the medium, their velocity will be v is equal to 1 by square root of mu and epsilon. Second, and what's this mu naught and epsilon naught are? Permeability of free space, permittivity of free space, and there v is equal to 1 by square root of mu and e. Mu is permeability of medium and epsilon is permittivity of medium. This third property, what is third property? The energy shared by electromagnetic waves is shared by electric field and magnetic field. They transfer energy and momentum. The ratio of magnitude of electric field and magnetic field is equal to the speed of the electromagnetic waves. Intensity is given by epsilon naught C in E RMS square, where E RMS is equal to E naught divided by 2. And at the last, at any instant, in the electromagnetic waves, the electric field and magnetic field are in phase. Understood? I hope you have understood the nature, definition of electromagnetic waves, the basic source of electromagnetic waves, and properties of electromagnetic waves. Simply you just understand that they are just the ones where electric field and magnetic field are mutually perpendicular to each other. Means if this is electric field, this will be magnetic field for sure. Then they are called as electromagnetic waves, and combinedly they are perpendicular to the direction of propagation. Understood? So this is all about today's class. In next class we will study about electromagnetic spectrum. Okay, thank you.